Good afternoon. Thank you so much for tuning in to our virtual presentation on biomimicry. As you were probably just told, we pre-recorded this presentation so that we can make sure that regardless of internet connection, it would still come through clearly for you all today. I'm coming to you from a farm out in Lake Butler, so I will pre-apologize for any possible farm animal or dog barking noises that may happen throughout this presentation. My name is Jessica Tittl, and I am an integrative bioscientist with over 6 years of experience in new technology and product design and patent design and strategy. Currently, I am working at the University of Florida, where I am working on a project where we are applying probiotics, which are good bacteria, to help stop the spread of coral disease around the Florida coast. But today, I would like to talk to you about one of my favorite topics, which is biomimicry. So we'll start off with what in the world is biomimicry? When we started discussing this presentation, we found that a lot of people really didn't understand what biomimicry was or had it confused with other terms or areas of study that are similar but not quite the same. Then we'll go through some examples of biomimicry in action. Then the biomimicry process, so how do we use biomimicry to solve our problems? And finally, I will be joining you all live for a question answer session. So, what on earth is biomimicry? Biomimicry is the imitation of models, systems, and elements of nature for the purpose of solving complex human problems. So one example of biomimicry would be the Japanese bullet train. The Japanese bullet train is a train that goes super fast, but it had a really big problem in that when it went through a tunnel, it would make a noise like a bullet coming out of a gun. And so the engineers decided they needed to find a way to solve that. They decided to employ some biomimicry and looked at a cool bird called the kingfisher that can actually dive into water without making a splash. By designing the nose of the train just like the beak of the kingfisher, they were not only able to eliminate the sound that the train made going through the tunnels, but they also increased the train's speed. Another example of biomimicry is Velcro. The fellow who invented Velcro actually took his dog for a walk in the woods, and when his dog came out covered in burrs, he had one of those eureka moments and said, "Oh my God, Velcro, that's ingenious." Now, some other terms that are synonymous with biomimicry are biomimetics, bioinspiration, bioengineering, and bionics. They all mean the same thing, which is taking the structure and systems from nature and applying it to your problem. But there are a lot of terms that are often confused with biomimicry. One of those would be bioassistance. So bioassistance is domesticating an organism to accomplish a function. This is something like using microbes to clean water. We take the microbe itself, put it into the water system, and that microbe eats up the contaminants in the water. So we're domesticating the organism to have it accomplish a function that we want it to do. There's also bioutilization. So bioutilization is acquiring or harvesting a product or producer. This is something like growing algae for biofuels or harvesting plants for medicine. We're harvesting those plants and using them directly for our medicine. A really cool area of science is synthetic biology. Now, synthetic biology involves redesigning organisms for a useful purpose. So we'll engineer them to have new abilities. This is often done in bacteria, where scientists will actually go in and change the genetic code of the bacteria so that they perform a new function. It's kind of like reprogramming a computer, but with bacteria. Now, biophilia is one that I hear confused with biomimicry a lot. And this is the concept of the human need for connection with nature and other forms of life. So biophilic design emphasizes bringing in elements of nature. This is bringing in trees and natural light to your office buildings. And it's done because people really are a lot more calm and relaxed and just feel better when surrounded by nature. Something to keep in mind while we're all working from home: put a potted plant on your desk, or make sure that you're working in an area with a lot of great natural light or by a window. It'll really help you relax in these times. And lastly, a term that's often confused is biomorphic. So what biomorphic is resembling or suggesting the forms of living organisms. This is something that's often used in architecture, like doing the honeycomb patterns on the walls or making a chair that resembles a shell. It looks like something in nature. But biomimicry is actually taking those models, systems, and elements of nature and using them to solve a complex human problem. So it's not just taking the general form or shape of a bird's wing for an airplane, but it's looking at what about that wing can actually make the airplane better, fly faster, use less energy, and how do we get into the nitty-gritty details of how and why these biological models work, and then being able to pull them from the biology to engineering terms or business terms, things that will actually help us apply them to our problems. So I want to talk to you about some biomimicry in action. And I tried to choose some areas that I hope are relevant for our times today during this COVID-19 crisis. So we'll go through digital networks, how honeybees helped shape the internet, corporate structures using biomimicry to design companies that can move fast in a fast-changing world. And of course, we would be remiss if we did not talk about medicine and how biomimicry has been applied to help with the transport of vaccines. So first, honeybees and the internet. This is actually a biomimicry example that happened a little bit backwards. So see, there was a fellow named Craig Tovey and his colleagues at Georgia Tech that designed what they called the honeybee algorithm. These fellows noticed that honeybees are able to find nectar without exerting a lot of energy into that search. So what honeybees actually do is they have scout bees that move around randomly around the hive looking for nectar. And if they find a really great source, they come back to the hive and they do what is called a waggle dance, where they dance around, and through that dance, they are able to tell the other bees in the hive the distance and location of highly profitable nectar sources. And so this allows them to allocate their resources to areas with a high benefit. Another important part about the waggle dance is that it takes a few minutes for the honeybees to understand what the scout bee is trying to tell them. And this gives a pause moment in the algorithm that actually turned out to be really important for its use in the internet. So what ended up happening is a gentleman named Sunil Nakrini came to Toby's office at Georgia Tech and told him that he has a problem. He needs to allocate resources so that all the servers are being used and can handle spikes during major events. You see, he had a bunch of servers that were being rented out to different organizations, weather, etc. And he only really got paid if the servers were running. This became a problem because he couldn't really predict the need for each server. You know, if there's a hurricane coming through, the weather servers would need to go up a lot more than others. When he described his problem to Toby, he thought to himself, oh my gosh, that is the honeybee algorithm. And they were able to apply the honeybee algorithm to the internet servers to help handle major spikes during major events and ultimately make our internet work more efficiently and faster. The next example is the superorganism company. As corporations grow, they start to move slower and can't really respond to rapid market change. I think many of us have probably worked in a big corporation, and we all know that the bureaucracy involved makes everything take forever. But in today's economic world, companies that move slow are going to die. They are the dinosaurs of our environment. But how do you balance the need and the desire to grow without making your company too lumberous and too slow to move and change in response to everything going on around you in the world? Well, the biological model here is superorganisms. These are genetically distinct individuals, each with a specific function that contributes to the whole, but they can't really survive long without the others. So what I think is one of the coolest examples of a superorganism is what is affectionately termed the wood wide web. This is the fungal network that is below your feet living in the soil. And this fungal network, even though they're distinct individuals, they send resources and chemical cues to everyone in this network. And it's also how trees talk to each other. Very cool. But what makes this wood wide web such a great model for companies is that these fungal networks are self-managed units that are able to respond in real time to attacks from a parasite or a plentiful source of food. And these units are able to respond and either protect the rest of the superorganism or grab a bunch of great food that they can then send to the rest of the superorganism. So if you structure a company without management layers, but with self-managed units that can respond and change in real time, then it will be able to grow really large, but not become a lumbering dinosaur that can't move and change with our fast-paced changing world. And lastly, we want to talk about biomimicry in medicine. They're called candy-coated vaccines. So the problem here is that vaccines require refrigeration, and many are lost due to breaks in refrigeration during shipment and treatment. So once we develop the vaccine for COVID-19, we have another problem, which is how do we get the vaccine where it needs to go? Especially when you're sending it to places like Africa that are very warm but don't have the same infrastructure that we might have here in the US to make sure that the vaccine is refrigerated both during shipment and while people are being treated. So the biological model for protecting vaccines was actually these cool little teddy bear looking fellows named tardigrades. Tardigrades protect themselves from extreme cold and dehydration by going into a dormant, sugar-coated, glassy state. Then when things are better, it's warmer, there's water, the world is great, they are able to rehydrate themselves and bring themselves back to life. This allows tardigrades to survive in some of the most extreme situations. They can even survive in space and rehydrate themselves once they're back here on Earth. Very cool little teddy bear animals. So the innovation here is wrapping the vaccine virus in trehalose, which is a sugary substance. And it actually keeps the virus alive and active for 6 months at a temperature up to 113 degrees Fahrenheit. Okay, so I told you what biomimicry is and what it isn't, and gave you a few examples of biomimicry in action. But you might be asking yourself, okay, great. Now, how do I actually apply biomimicry to my problem? So we'll go through a high level of the biomimicry process. Now, I like to set up the biomimicry process in 3 different sessions. And the first one is really just understanding biomimicry and defining the objective, because if you don't have your problem well defined, you won't be able to find the solution very easily. And the second would be sharing what we would develop are called bio leads. And I'll go through that a little bit more in just a moment to tell you a little bit more about that. And brainstorming to build upon what everybody finds. And finally, we would extract the design principles and define our lead projects, and even dig a little bit deeper to see if we can learn some more. So first, defining the objective and biofunctions. So here, what we would do is define what exactly is the problem that we are trying to solve. So for our example that we're going to run through, we want to design a new project management process to increase productivity and help our organization communicate. So we defined our objective, and then we would go through the biofunctions, which is really just asking ourselves, how does nature blank? So for this, how does nature send and process signals? How does nature build networks, coordinate ecosystems, cooperate, or self-organize? And then everyone would go out and do the research. There are lots of great resources to use to find examples in nature. One is asknature.com, which you can actually type in, how does nature self-organize? Or of course, you can go into the nitty-gritty of the scientific papers. You can go through Wikipedia or Google, or my favorite, which is just going out and exploring nature. You'd be amazed at what you can come up with just by walking out your front door and taking a walk and looking around you. We'd come back, we'd take all of that research, and we would create what we call bio leads. So bio leads are really just a form that helps us distill everything that we learn about a biological system and gets us asking the questions that we need to ask to start to brainstorm using them. So we have our objective to design a new project management process, and we know our biofunctions. So our relevant biological model that we came up with are colonies of social insects that self-organize and carry out complex group tasks through many simple individual interactions. So we'd ask ourselves some bio questions. What mechanism or strategy does the biological model employ to fulfill the biofunction? So how are these social insects self-organizing? How are they carrying out these group tasks? And what are these individual interactions? Then ask yourself, how does employment of this mechanism or strategy increase the biological model's ability to survive or reproduce? So why are they doing it in the first place? Then we'd come in and do one of my favorite things, which is brainstorming. So in the second session, you work in teams, you combine and expand on the bio leads, and you also would apply some new technology brainstorming methods to help break out of your box and develop something new. So we'd work together to try and expand on everything that we have found and learned, and ask ourselves how what we've learned can be applied to our problem. And then we'd extract the design principles. So we'd convert those biological functions and terms into ones that can actually be implemented into the product or system. So for the case of our social ants here, ants leave behind chemical cues. How might you then extract that biological function of the chemical cue to something that you can actually use when designing your project management team? Is there a cue that we can leave behind for the team when things happen? A email or a Google Doc or something that can show them that something has happened, maybe even a dry erase board in the hallway. And then from there, we would take those design principles and define our project. How are we going to accomplish our objective? So from looking at our social insects, we might consider that rather than a traditional team with the top-down leadership of a project manager, we could design a self-organizing team similar to the ants that can self-organize to take on all of their different complex functions. Or we might decide to do a scrum team. So a scrum team has different individuals that have different skills, but are very fluid and moving between them, much like the ants and the different skills that they employ within the anthill and that community. And after all of that, we dig a little bit deeper. So asking experts if they can find a professor that has been researching ants for his entire career and ask what more is there to know about how their social system works and how we might be able to take that additional knowledge and apply it to our problem, or bringing in additional models. So we might want to also look at honeybees and how honeybees use their social models to solve all of their problems and make their hive run effectively. And then of course you run experiments, because the first thing you try is rarely ever going to be the best thing you try. So you want to be okay with failure and with trying a bunch of different things. So you might design one project management team and run through a project and decide that some things were and were not working, and you'll reiterate and try again. So that's the general biomimicry process. You can take biomimicry and everything that you learn from nature and use it to solve all sorts of different problems, whether it's an engineering problem, trying to design a train that doesn't make any noise while it goes through tunnels, or a business problem, trying to design your company to be able to respond quickly to change, or project management groups that are able to self-organize and run projects effectively. There are a lot of great resources for biomimicry. I definitely want to call attention to the Biomimicry Institute, which runs Ask Nature, and they also have a biomimicry toolbox where you can learn a little bit more about the biomimicry process, and a Learn Biomimicry 3-course pack. You can find all of that by Googling Biomimicry Institute, and it's on their webinar or on their website. And of course, I have to give a call out to one of my favorite podcasts from the BBC, which is called 30 Animals That Made Us Smarter. So 30 Animals goes through 30 examples of biomimicry and how it was used to solve complex problems such as using shark skin to keep bacteria from being able to stick to surfaces. And it's a really great podcast, and I highly, highly, highly recommend it. If you'd like to talk about all this further, I also have a consulting firm called Biome Future, where I run through biomimicry and future forecasting sessions. I really love taking the time to look through trends and see how different industries are going to be changing in the future, and helping people use biomimicry to solve the problems that they are and are going to be facing. I am also the executive director for a nonprofit called Discover Biome. We started Discover Biome up in Ohio, and I've been starting to move it down here to Florida. Our mission is to inspire a global movement toward environmental consciousness and action through education, connection, and adventure. So if you'd like to contact me, my contact information is on the screen. And I also have the contact information for the Green Chamber of Commerce. I've loved being a member, and I hope you all will consider being members if you aren't already. But at this point, I will be live and available to take your questions.